Welcome to OIT's Math 451, Introduction to Numerical Methods. Now this quarter, you're going to find that we will be culminating all of the prior math classes you've had in the engineering program for Oregon Institute of Technology. This particular one is going to address some issues that we had, if you recall, from both calculus, differential equations, and also from other classes where we couldn't get the exact answer to a given problem. Calculus is an example with integrals. Indefinite integrals cannot usually be solved. They have to be especially formed integrals to get an analytic solution. And with differential equations, you have the problem even worse, where it's very difficult to get a formulaic solution without some tricks and without some specially formed problems. Even in linear algebra, the extent of the computations that you have to do end up becoming impossible just due to the numerical complexity and cumbersome nature of how those matrices have to be solved. In this course, we're going to deal with all that with the help of a computer, with the help of programming languages, and we are going to replace what we've done in the past with formulaic solutions, and we're going to be using precise stable algorithms as an alternative. So with that, let's take a look at our course logistics. This is a multimedia class. We will be using video, we'll be using our textbook, we'll be using some programming from various programming languages, and there will be some other expectations and rules of the game that we will discuss. My name is Tom Bingham. You see my email address there. I formerly was the manager of applied statistics within BR&T's Applied Mathematics group. You can get a hold of me through the email that you see there, but we will also be having pre-scheduled live workshops where we'll get together in the 1020 building in Renton and discuss the methods that we've been learning on videos. All of the lectures are on YouTube, and you will be given a catalog on how to get to each one. Your textbook is called Numerical Mathematics and Computing. It's by Ward Cheney and David Kincaid. This is an excellent resource to keep for a lifetime. It's got a great library of some of the more common numerical methods that are used, and we will only be covering about a third of the book. The rest of it is really a good resource for your library. And as far as software is concerned, you will need a programming language. We recommend MATLAB, and it can be downloaded using the link that I've indicated on the screen. But it will be okay for you to use other programming languages if you prefer, and if the teammate that you will be working with also agrees, you can use a different language. There will be some advantages to use MATLAB. We'll talk more about that in a bit. So what will we be covering? Well, for a numerical analysis class, it's really a good start to look at numbers, where they came from, how they've developed, but in particular, how they've been adapted to computer usage. We'll also go back and pick up some information from your calculus class, like the mean value theorem, and how it affects, or you can develop from it, Taylor expansion and Taylor series. And when we get to systems of linear equations, we will end up using the linear methods, the matrix methods that we got in Math 341, and we will adapt them somewhat to optimize their memory usage and their computational speed and accuracy. We will also talk about systems of nonlinear equations. Most of you feel like that you're already familiar with interpolation, sort of reading between the lines, but we will expand the notion of interpolation, and we will do that as a sort of a pre-step to developing something we call difference equations. And those difference equations are going to be extremely useful in differentiation. We'll also use other methods to do numerical integration and be able to solve any definite integral, meaning integrals with upper and lower limits that you come up with, where you couldn't do that in your regular calculus class. Through these same difference equations, we will apply them to differential equations, and we'll solve a few of those as somewhat of an appetite whetter for a very large subject that is handled in other advanced courses that you can take in other areas. So what do you need to take this course? You've got to have all your OIT math courses that we teach in this engineering program, except statistics. Statistics you can do at any time. You still need to do it, but we won't need statistics for this course, but we need everything else. So this should be really your last course that you're taking. Course attendance exists in two methods. The first is online course attendance. All 52 of the YouTube resident videos must be viewed, and when you view each one, you send an email to me along with any questions you might have about it, and I record the fact that you attended that video. That becomes an official part of your attendance record. The videos are roughly 10 to 15 minutes in length. You need to see each one at least once. You need to see them in order. Because they're sequential, each video builds on itself, and videos further down the course are going to be dependent on your understanding of earlier ones. So make sure you not only view them, but you feel comfortable with them before. As far as the online lecture links are concerned, I have an Excel file that I will send to you once you've officially signed up for the course. The file has 3 tabs. The first tab has all of the links for all 52 of the videos. It also has deadlines. It tells you whether there's homework associated with each one, and the names and the section numbers are consistent with the sections in the book so that your reading can go back and forth with the lectures easily. So let's take a look at that. Here are some of them. You have on the left the chapter number and the section in the book that chapter applies to, as well as a deadline when that video should be viewed. Now, Chapter 0 admittedly is of my own making. There is no Chapter 0 in your textbook. This is precursor information that will help set a better context for the rest of the book, and it is required. The title is there. Your YouTube link can be copied and pasted into your browser and run from there, and you can see the number of minutes that you can expect to be watching that. On the final right-hand column is a homework column. The check mark means that there is a homework embedded in that video. It's always towards the end of this little vignette. Don't move on to future videos until you've done the homework. It gets confusing if you're working from 2 different parts of the course content. So watch the videos in order. When you come to a check mark, do that homework before moving on, and get your video watching done by the date indicated. The homeworks have consistent dates with the videos. They're listed in a different tab of the spreadsheet, but they are aligned with these viewing dates as you see here on the 3rd column. So the second part of your attendance are these instructor-led workshops, or maybe I should call them tutorials. This is the list of the dates that the tutorials will be taught at. On the July 19th date, half of that will be a midterm exam. It will be the second half of the 3-hour section. On the 30th, you'll have your final exam in class. The whole session is devoted to the final. You'll have 3 hours for the final. You may not need all 3 hours, but that's all we will be doing on that date. So again, let's see how these homework and exams and grades turn into your actual scores. Again, the most important part of the course is 30% of the grade. That's homework and programming projects. If you learn them well, you should do well on the midterm, which is another 30% of your grade, and the final, which is 40% of the grade. Those 2 tests will be directly related to your homework and programming projects. So make sure you thoroughly understand the homework. There's 26 of these homework assignments over the whole course. You may share your code with your friends. Anybody in the class is fair game. You can discuss it, look at their code, have them look at your code, come up and agree with methods. It'll help you get through these assignments. But what you don't want to do is just copy their code. You won't learn anything. So write yours yourself, but certainly do it in a collaborative manner. This is somewhat time consuming. It's going to take you 2 to 4 hours per assignment. Not all assignments are equal. Some are harder than others. But this is a 400 level class, and there is a level of work and abstraction that's expected from that. So your homework will be submitted to a partner. So you need to choose a friend or just an associate who is willing to grade your homework, and you will grade your associates or your partner's homework as well. I am like these to be in teams of 2 if possible. You'll grade each other's work. I will have some criteria for each homework you go out, and then you will send it to the grades to me. Once you have shared your homework with your reciprocating partner, that is my cue, because you'll CC me on that. That's my cue to send you the solution sheet so that you can effectively grade the work. Do collaborate with other class members. It doesn't have to be just your team member. It can be, but anybody in the class. Don't go to some expert resource either online or some other place in Boeing. Don't go to them because you're not going to learn anything and you won't do well in the midterm and the final, but work it together as a class. PDF files make it really easy if you just scan your homework and send it, but if you've got actual programmable script, then you want to send the actual M files or whatever source code is applicable for the program that you're using. You can issue me questions, which I will bring to our workshops, and we can discuss them as a group, but I will do no one-on-one work with any student. That is expected to do yourself or with your friends. Don't forget these assignments are cumulative, so if you don't understand one, you're probably going to have trouble with some other one, and in many cases, some assignments are literally edits of a prior one, so you need to make sure that you understand before you move on. And also, I am encouraging your team members to be liberal in the grading. If the person didn't get it right but did a lot of the right stuff, give partial credit. So the submitted work, the graded work, must be to me 5 days after the due date. If it's even a second after that, everybody on the whole team is going to lose 50% of their scores. It's also bad for everybody to get behind. You really don't want to do that. Now, this is the second tab on the Excel file that I will be sending you. The names of the homework assignments are going across this row. There's 26 of them, and the 2 exams are indicated as well. The numbering on this list is consistent with the numbering assignment of the sections you'll be reviewing, and those are consistent with the book section, so it should all line up very nicely. The due dates are indicated here. Look, this one is really short fuse. June 27th is coming up quickly. And this last statement down here on the bottom is if you send code to your friend and says, here it is, but it doesn't run at all because there's syntax errors, that is the only time you should get a 0. Okay, on the executable scripts, here's how you want to grade it. First, did it get the right answer? Secondly, what were the number of points that was available? You'll see that on the solution sheet. Was it accurate? Did it have a good computational speed? Was it careful with memory usage? Were the lines commented so other people can read what you intended to do? And do you have logical indenting of if statements and while statements and for statements and so forth? So that should all be done carefully. As far as other criteria is concerned, if it's a math development you're doing, and you go from step 3 to step 4 and there's no way to get from step 3 to step 4, that's no good. You have to have a logical sequence of work. And finally, your grades, you're used to that already. These are the OIT standard and grades, and these are the grades you'll get based on the percentages that you actually earn. As far as getting your programming language, again, there's the link for MATLAB. It does cost $99. Some groups at Boeing have their own access to MATLAB, so you might be able to use that. When you order it, you will get both MATLAB and Simulink. We will not use Simulink. It will also ask if you'd like some of the add-on packages for $29 a pop, and you don't need any of them, so don't bother because you're not going to be able to use them. After you turn in your solutions, I give you the results, the solution set, in MATLAB. So it'd be easier to grade it if you had the MATLAB solution set, but if you're okay with doing the translation in your head to another language, then that's okay. Also, when you are using MATLAB or any other language, don't use the functions that are in there that just do what we're trying to program. You won't learn anything and you shouldn't get any credit for that. It's better if you put all your source on a single file. You can use inline functions, that's okay. But if you use multiple files, it makes it harder for your grader to grade it. So that's just a recommendation. Or when you submit either the source files like the M files for MATLAB or PDF files for other homework. Use homework names that you and your partner can understand well, and it's just easy to follow. It just makes it easier for everybody. So that's the end of this section. You've now completed, and I'm very much looking forward to meeting you in person on our first workshop.